All right, now, guys, this is really this should be a review for most of you guys from 8th grade science or middle school science. I know you guys had a lot of earth science, so I'm always wondering why we often this is the high school level, but okay. All right, so layers of the earth. Kind of start with this really weird looking shape, and I somewhat have modeled this to scale. It's not necessarily perfect, but we have 5 layers that we're going to look at for Earth. And the big black dot is the black dotted bit. Tommy.
Our core.
Yes, it's the core. But there's actually 2 parts to the core.
Core and the
Let me put it this way, the yellow and the dot are all the core. So that would be the inner core. What is the yellow region? Outer core. What's the big red section? Makes up over 80% of the volume of all of Earth. Anybody know? Big, thick section? That's the mantle. And then, the thin little light brown here, that's a new layer that a lot of people forget about. It's called the asthenosphere. And finally, all the way on the outside, we have the crust. A couple things that's worth mentioning. The radius of the Earth is only 4,000 miles. That's it. So if you were to go from New York to LA, let's just say New York to Hawaii. It's not, I mean, it's a long way to go, but it's not an overly expansive trip. But instead, if you were, instead of going east and west, if you actually were to go deep inside the core, that's about how far it is from the crust, tip of the crust where we are today, all the way down to the center of the core. About 4,000 miles. Quite far. Yeah, it doesn't really seem that far at all. 4,000 miles. We're going to have a lot. Maybe what we're going to look at today is looking at the ratios and proportions that we see within this. When we look at these layers, the question I have for you next: why this particular order? What actually determines these things to layer themselves out? Why do we have the inner core, the outer core, the mantle, the asthenosphere, and then finally the crust? What really drives all them to? Why aren't they just all kind of there together? Why do we even have the layers? What's the driving mechanism that makes the Earth become layered? Tanner? Say that again? Yes and no. You're right, in terms of from our molten state where everything can just kind of exist together, when we start cooling, those things start to settle themselves down. But no, it's gravity. We consider gravity with density. Think about 2 fluids, water and oil. Put them together, what happens? Yeah, oil just on top because it is less dense than the water, okay? Same thing with this bottle that you guys always keep coming up here and shaking, right? These 2 beads are 2 different densities. So when I shake the bottle, they're all shook up together, right? So think about this in terms of the molten state. Okay? But then given enough time, as they start to cool, what happens? They separate, and then they start to layer themselves out based on their densities. So when we look at the Earth itself, what you're actually looking at are layers of density. And so that's kind of important to look at and understand what that actually means. So, what does that tell you about the inner core? If it's all the way at the inside, what does that tell you about the inner core? What does it tell you about the density of the inner core? Least dense?
Most dense.
Most dense. Excellent. So the most dense. What's the least dense? Crust. And that's where we live. So what we're doing in this lesson is we're actually going to go forward and look at each one of these layers in more detail. A lot of bullet points today. Not a lot of pictures.